Welcome back to Balvigan Bharti with mentor Abhila Sarkar. In this chapter, we will move from the problem number 33. So, the problem number 33 in binomial series, it comes like that. 33. It says, in the binomial expansion, in the binomial expansion of a minus b whole to the power n, where n less than equal to 5, the sum of fifth and sixth terms is 0, then what is a by b? Now x is being limited to less than equal to 5 and n cannot be negative. Okay, so in this case, if I assume that the maximum value n is 5, then only I will get fifth and sixth term, because this maximum power is n, so number of term will be 6, so maximum, and we are talking about fifth and sixth term. So fifth and sixth term will only come if in case the n value is equal to 5, only then fifth and sixth term will come when expanded, isn't it? So expanded. So below that we will not get the fifth and sixth term. Okay. So we can assume that n is equal to 5. So in that case, if n is equal to 5, then what is your fifth term? So this will be r plus 1 case. So n c, what would case, and that case we can assume it is maximum power is 5. So 5c 4 will be the case. A to the power 1, 5 minus 4 1, and minus b whole to the power 4. So this will be the case where I will get sum of this. Okay, sum of the binomial expansion, the sum of the fifth and sixth term means I have to take the whole term, not only the coefficient. I have to take the whole term. So this is fifth term, and sixth term will be equal to 5c 5 a to the power 0 minus b whole to the power 5. So now, as per the rule, as per the condition, t5 plus t6 is equal to 0. Okay, so now if I put the value 5c4 a minus b whole to the power 4 means b to the power 4, and plus 5c5 a to the power 0 means 1, and b will be minus, so this will come as minus b to the power 5 is equal to 0. So then b cannot be 0, so b to the power 4 can be cancelled out, so remaining will be 5c4 a minus 5c5 b is equal to 0. So a by b we have to calculate. So if I accordingly shift the other constants, so a by b will be 5c5 by 5c4. So that is equal to 5c5 means 1, 5c4 is equal to 5. So 1 by 5 would be the answer. Okay. Moving to next 34. The problem is 34. 34. Okay, if 1 plus ax whole to the power n, when expanded, we'll get something like that: 1 plus 8x plus 24x square plus dot dot dot. Then we have to find the value of a or value of n, or both we can find. So what will be the values of a and n? So generally if we expand any binomial series, we'll get some form of the expansions, and that is equal to, as per the rule, nc0 1 will be there, so that does not have any impact. nc1 ax whole to the power square, sorry, ax whole to the power 1 plus nc2 ax whole to the power square and plus dot dot dot. So two terms is more than enough, because there we can compare the terms. So now this is equal to this. So what is your nc0 is equal to 1. So anyhow nc0 is always 1, even any value, for any value of n could be any value. Okay, belongs to an integer, you can say. So this for any value nc. So this will not give you any information. So what are the information? From where we can gather nc1 a to the power 1 and x to the power 1. So nc1a will give you 8. So this is one information where you can decide something. So and nc2, the next one, a square will give you 24. This is another equation. There you can find any value of this. So what is your nc1 is nothing but n, a is equal to 8. nc2 means n into n minus 1 by 2 into a square is equal to 24. So now if I eliminate, let's say a, so here if I put the value of a, n minus 1 by 2, so a is equal to 8 by n whole square is equal to 24. So if I remove the bracket, I will get 64 top and n square. N can be cancelled out. So this is 64 to 32, further 8, 4, 8, 3. So ultimately 4n minus 4 will give you 3n. So n is equal to 4. So one information is okay. Another information, n into a is equal to 8. From there, if n is equal to 4, a is equal to 2. So this is your requirement, a and n. So you can find it from there. Okay. So moving to the problem number 35. The ratio of the coefficients of x to the power 15 to the term independent of x in the expansion of x square plus 2 by x 4 to the power 15 is how much? Now that you have to find. So this is a very basic rule. What we have to find? We have to find the general term of that expansion in r t r plus 1, that we can find anyhow. The 15cr, the term x square will get 15 minus r in as a power, and the second term will get power of r. Now if we simplify this, so basically 2 power of r will be eliminated, will be separated from that x, and x will get ultimately x squared, that means 30 minus 2r, and this r will come together. So from there, if we further write the term x to the power 3r 30 minus 3r, so this will be the simplified form. Now the ratio of the coefficient of x15 to the term which is independent of x. So for x is equal to 15, 30 minus 3r will be how much? 15. Okay, so this will be 30 minus 3r means 3r is equal to 15 and r is equal to 5. So if I put r is equal to 5, so 5 plus 1 will give you x to the power 15. So 15c 5 2 to the power 5 into x to the power 15 I will get, and for the second one 30 minus 3r has to be equal to 0 because it is independent of x. So from there r will be equal to 10. So here t 10 plus 1th term, what is the coefficient? Let me see. 10, 2 to the power 10 and x to the power 0, that means no x. So now we have to find the ratio of x15, this means this, the coefficient. This only you have to take for the calculation, final calculation, and this. So the ratio of coefficient is equal to 15c5 2 to the power 5 divided by 15c10 2 to the power 10. Now you see 5 and 10 together will give you 15. So these are equal. I can eliminate it. So ultimately how much it will remain? 2 to the power minus 5. This is 2 to the power 5 by 2 to the power 10. So if I adjust the power, it will be 2 to the power 2 to the power minus 5. So your ratio, the answer will be 2 to the power minus 5. This will get as an answer. Okay. Moving to next problem, that is problem number 36, I think. 36. Okay. Can you see it? Yes. So the next is in the expulsion of 3 under root a by b plus 3 under root b then root a whole 21, the term containing same power of A and B is what? So this is an binomial series is given, and the term containing the same power of A and B. So let me assume the term will be tr plus 1. So from there, the tr plus 1 of this series will be 21cr, the first one. Second, first term whole A by B whole to the power 21 minus r, and the second term 3 into under root of B by again A whole power of r. So this will be the expansion, and now we have to simplify and we have to keep all the A power in one place and B power in one place. That is my first target. Now these coefficients we can eliminate from here by separated from A and B. So 3 to the power 21 minus r and 3 to the power r all together, this will be 3 to the power 21, because 3 to the power 21 minus r plus 3 to the power r will be eliminated 21. So I can separate out all the constant. Now talking about power of A. So this is whole power of A. So A to the power half, so 21 minus r by 2, and B to the power 21 minus r by 2, the first one. Second one, if I eliminate the root, so that will give B as half power. So B to the power r by 2, and this is under root of under root, so A to the power 1/4. So this will come as r by 4. So this is the simplest one. Now keeping this thing same, A power will be adjusted with A. So 21 minus r by 2 minus r by 4, because from denominator it will go to numerator. And if I adjust B, let's say B I am keeping below, 21 minus r by 2, and this will come down r by 2. So now as per the condition, the power of A and B are equal. So this is power of A, this is power of B. These are equal. So I can equal it. 21 minus r by 2 minus r by 4, that is equal to 21 minus r by 2 minus r by 2. So this will be how much? 4 will be LCM here. So 4, this will be 42 minus 2r and again minus r, and this side this will be 2 will be LCM, 21 minus r minus r. So this 2 will be cancelled out. So ultimately what you have to buy expression term you have to find. So anyhow I will get the term. So I will rub the upper part for calculation. Now this will become 42 minus 3r this side, and this is equal to 2 into this is 42 again minus r minus 2 into 2 is 4r. I don't know it is written a perfect way or not. This is cube root or 3, because this seems to be 3 only, 3 multiplied. But in this case you can see, if this is the equation, this is only can be satisfied for what? R is equal to 0. Okay, so if I can assume this is true, and for R is equal to 0, what would be my term then? This anyhow are equal, because as per the condition a and b power is same, so this we can cancel out. Whatever be the case, if I put the r value, ultimately a and b power will be same, so we can cancel. No, sorry, we cannot cancel it. If I put, sorry, I made a mistake. If I put r is equal to 0, then power is same, so that means a will become how much? 21 minus r, this is coming ultimately how much? This is coming a to the power 42 minus 3r is coming by 4 is coming here, and this is coming as b to the power for 21 minus 2r by 2. So now if I put r is equal to 0 here, so my a power will become and the term will become 21c0 3 to the power 21 here, and a power will become 42 by 4 and b power will be 21 by 2, or you can reduce it by 21 by 2. So both power are same, so ultimately my term will become 21c0 and a by b under root whole to the power 21 by 2 both the case. So under root of a by b, so this will give you the same answer, because our a and b power is same, that also being established, and the term will carry another 3 to the power 21. So this is the term where a and b power will be same. Understood? So I end up here. The next video I'll come and start from 37. Let me write it there. Don't forget. The term, the number will be 37. Thank you for now.